Okay, so now we're going to do the Introduction to Web Dev quiz number 3. In this one, we're going to be going over promises, asynchronous/synchronous programming, and .then/.catch. Same format as always. I'll read the question. You pause it if you want to think about it. I'll go over the answer. So let's go over the first question. First question, event listeners are an example of blank JavaScript. A, asynchronous, or B, synchronous? Yes, the correct answer is A, asynchronous. So before we can answer this question, let's sort of talk about what asynchronous JavaScript versus synchronous JavaScript is, right? So I have these two little diagrams, and they correspond to each of these. So when we think about synchronous programming, it's sort of like event A happens in its entirety, and then event B happens in its entirety, and then event C happens in its entirety. So it's kind of like a step-by-step process versus asynchronous programming, where we've got all of these events starting at the same time and running at the same time, right? So one thing you'll notice is with asynchronous programming, the time it takes to finish these tasks is much faster than the time it takes for synchronous programming. The reason why is because, we don't need to start one right after the other one stops. We can just start them all at the same time. So that's one benefit of asynchronous programming. So going to event listeners, why are event listeners an example of asynchronous JavaScript? The reason why is, we just set up a callback that happens when a user clicks on a button, but we're not going to pause everything from loading on the screen before the user presses on the button. This button click could happen at any point in time while the user's loading, or while the user is looking at this website. So we're not going to wait around for the user to press the button. What we're going to do is we're going to say whenever the user presses the button, that's when we'll fire off event A. Meanwhile, we can have event B, event C in the background. We can overlap these because of this uncertainty, right? It would be such bad web dev design if your website, let's say that there was another button, and if you press it, something else happens. But what we do first is we wait for someone to press this button, and until someone presses this button, this other button won't do anything, right? So if you can kind of apply this to like your idea of what websites should do, all buttons should be responsive, and all event handlers should be asynchronous. All right, next question. If an error occurs in the middle of the cook method, what will happen? And then we have this line of code where we're calling by pasta, just some random function, and then we're saying .then cook, .then eat, and .catch complain. A, the eat method will run, and then the complain method will run. B, the complain method will run. Or C, we will skip over this block of code entirely. The correct answer is B, right? So let's sort of break down this .then catch structure. So first, we're running this by pasta function. It presumably doesn't run with an error, and then we're passing whatever the result of that function is into the cook method. And within that cook method, we get some sort of error that causes the cook error to not return a promise that has been resolved. So what we're going to do is we're going to go down the .then catch structure until we reach a catch statement. And what we're going to do is we're going to run the complain function. The reason for this is sort of the reason why we use the .then catch structure. If something fails, so we'll say this is step 1, this is step 2, and this is our error. If an error happens at step 1, we don't want to move on to step 2. That wouldn't really make sense. We want to catch our error and deal with it. So we're not gonna run the eat function because we had that error. and we're not going to skip over this block of code because we have that catch. It's kind of like a catch-all, If we have an error either in the buy pasta or the cook or the eat function, we're going to catch that and we're going to run complain. All right. Next question, similar but a little bit different. If an error occurs in the middle of the cook method, what will happen? Then we have this block of code, buy pasta, then cook, then eat, then catch, then do more. A, the complain method will run. B, the complain method will run, and then the do more method will run. Or C, we will skip over this block of code entirely. The correct answer is B. So just like before, we've got this error in the cook method. What that means is we're going to skip over the eat method and we're going to run the complain method, which is, we're not doing step 2 if step 1 had an error in it. We're going to move down to our error handling function, which is complain. However, what's different here between this problem and the last one is that we have another .then after the .catch. So as I mentioned, the catch is responsible for errors that happen above it. It's not responsible for errors that happen after it. And what we're saying when we add another .then after the .catch is run this method after the .then, and then let's say there's no error, we would run the other .then. But this is kind of why you don't want to end any .then .catch structure with another .then, is because we're gonna run the do more. We're gonna run the do more function. So you really want to have the .catch as the last statement within the structure, so that you're not running more functions, even though you've had an error somewhere higher up in the structure. All right, next question. Which of these is not a reason the .then .catch structure is useful when working with promises? A, we don't need to wait for promises to resolve to continue with our code. B, it can handle errors gracefully. C, no need for giant callback pyramids. Or D, it's faster than not using it. The correct answer is D. And I kind of go, I'll kind of go through each of these, explain why they are true, and then, D is the odd one out. So with A, one benefit of the .then .catch structure is, as I mentioned before, the asynchronicity of the code. So when we set up this code here, we're saying, okay, the promise, we want you, as soon as we make this promise, if it's successful, we want to run whatever function is in each of the .thens, and then if we have an error at some point, we're going to catch it and run this function. But while all that is happening, we can move on to the next line of code. So as while this is running, we can run this as well. So we don't actually need to wait for them to resolve. We can just keep moving on. And, if they don't resolve, if they reject, we can catch those errors as well. So that's one reason why the .then .catch structure is useful. It can handle errors gracefully. This is also true. So assume we have this function order on Amazon, and I don't know, it's a buggy function. All it does is it rejects the promise. And so when we make that new promise, order on Amazon, we assume that this promise has been resolved, but it hasn't. So the value of pants it doesn't exist. So then, we don't have a .catch in this after this .then, so it's not going to catch that error. So it's really just going to crash as soon as we try to put on these pants that are non-existent. So if we had the catch, it would have caught that error, and we could have, printed out like the pants don't exist or something like that. And then C is no need for giant callback pyramids. Yes, this is also true. So here's a common little joke. This is the guy from Mortal Kombat, I believe. So with the .then, you kind of have like a really nice structure where you're just, even syntactically it looks nice. It's clear. this is step 1, step 2, step 3, and this is our error. You know, versus where we've got nested callbacks and it just looks horrible. You know, reading this is also kind of hard. Okay, you're saying, so we run A, and then we run B, and we have to like pass in results from A, and we have to define a new struct, we have to define a new function. Within that, we have another callback, another callback, another callback, another callback, blah, blah, blah. And then only once we reach, you know, the final step can we do whatever we need with the result. This is much better syntax. And then D, it's faster than not using it. This is just, you know, not